yes, so we are discussing about this electricity itself. So what exactly is current? For suppose we have current, right? So the flowing charge, what exactly the charge flow? If I come to, we have known that current is denoted by I. You must have heard this word, current I, right? And its unit is ampere, right? So in our circuit, what exactly flow? In our circuit, what exactly flow?
Volt and current.
We say now that current is what? Current is flow of charge. Flow of charge per unit time. Current is what? Flow of charge per unit time. We say this thing, we say this definition now. But which charge exactly flow? Which charge? Electron, exactly. And electrons flow from where to where?
Negative to positive.
Exactly. Electrons flow from this direction to this direction. This current is called electronic current, right? Electronic current. So, but you must have studied that teacher is telling you that current direction is from positive to negative. All of you heard this thing? That current?
Yes, sir.
Start from positive to negative. What is this thing? What exactly this thing flowing? Think? Is that something flowing from positive to negative? Nah, nothing. If you think that proton is going to move, no, proton is in the nucleus itself, where it will move. The only thing which can move is electron, right? Getting my, I'm talking about very basics. You know, current equal to Q by T. All of you heard, na? Current equal to charge by time. Which charge, sir? Electron, sir. Charge by time. Anywhere it come, proton. Proton is moving from plus to minus. Anywhere it come in the formula. What comes is your charge of electron only. Everybody is understanding my point? Okay. So I'm telling you what exactly is happening. Okay. If electron is losing somewhere, if for suppose there is 10 positive charge, that is proton, and some 10 negative charge, so that is electron, right? So what is the net charge? 10 positive charge and 10 negative charge. What is the net charge on this body which has 10 positive charge and 10 negative charge?
Is equal to A की value आ गई 8.
Think? Abdullah,
829.
what is the net charge? If it has 10 positive charge and 10 negative charge, what is the net charge?
8 plus
0.
8 14 64.
Okay. So what I'm trying to say, if someone, what happens when someone lose electron? This negative part is losing electron, na? Lavanya, this part is losing electron, right? Negative part. So what exactly will happen when it lose electron? For suppose the situation comes when there is some 10 proton only, and now it becomes 9 electron only. So what is the net charge? Hello Blossom, welcome. What is the net charge? 1 positive charge only. All of you agree with this thing?
Yes,
so
yes.
So what I am trying to say now, someone if it is losing electron, it is getting positively charged. So we say that something is going to flow this side. The positive charge is flowing from positive to negative. Nothing positive charge is flowing is itself. Only thing which is flowing is electron is lose. Electron is this part is losing this electrons. And if it is losing the electron, it is being said that positive is coming to this side. Nothing positive is coming. Okay, that's why you like study that something from positive side going to negative side is called conventional direction of current. Conventional direction of current, which is going from positive to negative. And that you study I equal to Q by T. But the point is that the current which I you are thinking na, was actually the electrons only which are flowing from negative to positive. So make it simple. We are taking this direction positive to negative from that we consider this as conventional direction, positive to negative. But exactly what flow? Electrons flow from negative to positive, and that direction is called electronic current. Okay. And how you are saying
Conventional direction is positive.
yes, we
Negative to
consider
positive.
it as positive, but exactly nothing positive is flowing currently. That I'm trying to say. What is happening exactly? This side is losing electron, and someone is losing electron. It is itself getting positively charged, right? 10 positive and 10 negative, no new net charge. But someone, if it lose electron, for suppose here, I tell you that this part has 10 electron, and now it has 9 electron. So now it get to acquire how much charge? 1 plus charge now. So now this terminal is getting positive charge. Where? So we tell that this positive charge is flowing, but actually nothing positive is flowing. Only thing what is happening is that this part is losing electrons, and that why now it is have positive charge. So we just say that this is the conventional current. Okay. So now this one is the very core point. Okay. And if you don't have difficulty in understanding, let it be easy. Just you must know that current equal to charge. Whose charge? Electron charge. Because electron is exactly flowing in the wire divided by time. Okay. For suppose I'm giving you a question. I want to hear whose answer is first. Okay. So for suppose there is a battery. Okay. And I have gave you, I told you the electron is flowing. Electron is flowing. So if I tell you that here 100 electrons flow, 100 electrons flow, 100 electrons flow in 50 seconds. 100 electrons flow in 50 seconds. What will be the current?
2 ampere.
Ampere. 2 ampere. 2 ampere.
All of you agree with 2 ampere?
Yes, sir.
Yes, sir.
I'm repeating the questions, okay? That the electrons here is 100 electrons only here, okay? And these 100 electrons flow in 50 seconds. I'm asking what is the current, okay? So all of you know that current equal to charge by time. Agree? Agree all of you? Devanshi?
Yes, sir. Yes, sir.
So, but I given you charge. Charge unit is coulomb, but I have given you number of electrons. Think? Charge has a unit of
Coulomb.
coulomb, but I haven't tell you charge. I have told you electrons which are flowing now. Someone who don't understanding anything, now I'm connecting. All of you must remember that one electron has a charge of how much charge one electron have? Blossom? No one knows what is the charge on one electron.
1.6 into 10 to the power minus 19.
Exactly, 1.6 into 10 to the power minus 19 coulomb. At least if you are not knowing this, you must remember, okay? One electron has a charge of 1.6 into 10 to the power minus 19 coulomb. So what I ask you, 100 electrons. So 100 electrons has a charge of, what you will do? Has charge of? Has charge of? How you can find? 1.6 into 10 to the power minus 19 into 100. 100 can be written as 10 to the power 2 or equal to 1.6 into 10 to the power minus, you can all be live, okay? Don't hesitate, okay? Be very frank. 10 to the power minus 17 coulomb. This one is the charge, okay? So now you come to know the charge is 1.6 into 10 to the power minus 17 coulomb. And what is the time?
50
seconds. 50 seconds. Now you can find this one. Okay. So whatever this calculation, this will be your answer. Something 0.0.000 something will be, because I have taken from my side. So that's why it is Hana, you can see calculations. Okay.
E की value है
So all of you got my point that current equal to charge by time. Why charge? Because charge is flowing. Okay. And if some charge is flowing, it must take some time.
अब हम लोगों ने
Right.
यहाँ पे एक
So
बात करना है,
whatever the current, I will find by charge by time.
n into
Now I was
1.75
coming to a point which is called voltage, right? Let me. Oh, so horrific scene, right?
plus
Ha, this concept. What I'm trying to say about voltage. You must have heard voltage, but you must not able to realize what exactly this voltage is doing.
minus
Right?
5
Voltage is the unit of
कितना आ गया
potential,
7
Potential
potential
है ना?
difference.
Potential difference.
Exactly.
1.50.
I want to make you understand how exactly this is working.
N is equal
Okay.
to
What exactly is this potential
7.50.
difference? Okay. So if no one is knowing about, if anyone is not have idea, have believe me, Hana, hear me. Okay. I'm explaining.
Upon 1.75 ठीक है
गुड इवनिंग सर। हेलो।
Good evening, पृथ्वी आ गए आप?
हाँ सर। सर बोल रहे हैं कि किस चीज पर, मतलब कौन सा टॉपिक पर हो रहा है पढ़ाई?
आप ध्यान ही नहीं देते हेडिंग पर, इलेक्ट्रिसिटी। ओके।
ना, हाँ इलेक्ट्रिसिटी हो रहा है, लेकिन उसमें कौन सा मतलब?
आप देखिए समझ में आएगा, ठीक है ना? ऑल पॉइंट्स आई एम कवरिंग। ओके। So let's suppose I
ठीक।
taken a bulb, Prithvi has taken a bulb without battery. Will this bulb glow?
No, sir.
No. Why? Why?
No, sir.
Why?
Sir, the battery is not
There will not be any
connected.
flow of charge.
19 वाला रुको
Charge is within a conductor. Conductor, we have no wire. Wire have their electrons.
19 सुबह
Right? Electron means electrons are from where electrons come? This wire has electron, right? But no one is forcing them to move, right?
ऐसे ही होगा
And what I'm telling that these wire has electrons, but no one is forcing. Hana, when you wake up in the morning and told,
ठीक है
हम नहीं जाएंगे स्कूल, mama tell you, force you, उठो जाना है स्कूल, right? Someone to force you, go, Hana, right?
ये भी समझ में
What exactly this battery now coming is doing the same, telling
बाकी
these electrons
लगाओ,
move.
और जो क्वेश्चन फंस रहे हूं वो खटा कर
Okay.
देना, ठीक है
See, for suppose
चलो बाय बाय
this battery is providing you what we is called potential difference. What it is called?
सेशन को भेज रहा हूं
Potential
Potential difference.
difference. If you want to means realize it in synonym, na, it is working same as electrons. Bhago, chalo, you must move. Nalayako, chalo. And that thing is done by potential difference. If you don't apply any battery, electrons in the wire is not going to flow. Right? So this is making the electrons flow. Okay. And how this potential difference is coming? Okay. Let me explain you. All of you have studied the formula, right? Potential difference equal to what? Potential.
Yeah.
Sir, that like charge.
Potential difference denoted by V equal to
I
Current into resistance.
Is this okay? Work by charge? All of you heard? Joule per second. Now you will tell, sir, ये तो हम पहले से जानते हैं. Yeah, it's okay, but we have to study, right? So let me tell you, this one is a battery. This one is a circuit. This one is the bakwas bulb. And this one is the, okay. So
Hello?
what exactly we have, I was telling you, someone is making force,
हाँ,
right?
एकदम
आगे बढ़ो, you must move. So for suppose this one is a positive charge, right?
हाँ
Okay. And I am taking, this one is a big positive charge, for suppose it is 100 coulomb, for suppose, plus 100 coulomb, okay? And now
हाँ
you are taking a one coulomb charge here, and you want to try that this coulomb must move along this. What will happen? Positive will repel each other.
तब तक के लिए जो तुम्हारे सेशंस रहेंगे
This is a big 100 coulomb charge, and I am taking a 1 coulomb charge and telling him to bacha move along this. Will he try to move along this?
8:30 के बजे
Yes or no?
दोनों ही सेशन में ठीक है ना एक 7 बजे
If
का
both
सात
are positive, then
और
it
एक
is
7:30 के
not
बाद
possible.
ठीक है?
Definitely, it
और
will
उसके बाद
repel.
exam,
Positive, positive
ठीक है?
repel each
जब
other.
तक exam चल
Okay?
रहा है, ठीक है?
Positive, positive repel each other. But still, I want that it should move along this direction. What you have to do?
ठीक है?
You have to
Force.
एक
you have
पहली
to
वाली,
apply the
हाँ,
force.
ठीक है?
If you want this 1 coulomb to come this point,
हाँ, मैं message कर
okay,
रहा हूँ।
you must apply some force. And if you apply some force, there must be some work
मैंने
done.
message कर दिया, WhatsApp पे check कर लो।
If you apply some force, it must
Timing जो बता दिया है,
work will be done. So,
ठीक है ना?
what I potential difference trying to do is to push these charges. Go, bacha, jao, school jao, go.
ठीक है, अपना
Okay?
WhatsApp on करके देखिए।
And to whom they are telling, bacha, no charge. Bacha ko to school force karna hai na, mama. That you should go to the school. But here, I have to force this charge to move. So I have to work. And this is done by potential difference. So the formula is work by charge. I'm not telling that you know the formula. I'm trying to convey you why is this formula. Potential difference equal to work by time, work by charge. Because charge are told, bacha, you should move. Okay, right? And that's why I'm in the very early, I was taking this point where I'm telling that, yeah, there is some tanki, this cistern is at your floor, okay? And this one, some motor is underground here, okay? And if you want this water to come to this point at from lower level to high level, there must be some push, that is motor, Hana, that push this from low level to high level. So this is an analogy, Hana, here motor force this water to come up. Similarly, just a second, please silence. So similarly, the same thing is done by potential difference in a circuit. Okay, they have to move the charge. Okay, and for that there must be some work done. Okay, so let's take a question. Okay, what I'm trying to say now, those who are not even knowing this now, I'm taking the point that so much likely that even you watch this video, you can understand, okay, your concept, and that is okay for you. So now what I'm trying to say, potential difference equal to work divided by charge. Okay. So if I give you a question that in a circuit, we want to move, for suppose we want to move 1000 joule. Okay. Sorry. For suppose there is a battery which can work, which can have a capacity to work 1000 joule. It can force the charge to how much work it can done, because this work will be done by battery. Mama tell you that go, the same battery will do the work na. Okay, this battery can provide 1000 joule. Okay, and this is making effect on 50 coulomb of charge. Okay, so what will be the potential difference of this battery? Hear me first. What I'm trying to say, that this battery can supply a maximum of 1000 joule, and this 1000 joule is capable to move only 50 coulomb. So what is the potential difference of this battery? When you buy a battery, there must be some 12 volt, 220 volt written there, right? Right now, all of you have seen a battery, something written 220 volt battery, 122 volt battery.
Sir.
So what is this volt? These volts show you, if suppose someone is telling, for suppose there is a battery written 12 volt. Okay, what it mean? Anyone can ask you, now you have studied electricity, right? So if someone asks you, what bacha, you have 10, you are passing 10, what is the meaning of this 12 volt in a battery? You say, sir, no one has taught me. Hana. So you first realize how how you can realize from this formula only. Potential difference equal to work by charge. All of you agree? You know this thing? Work by charge. I connected you on
Yes, sir.
also why this formula is. Okay. So now you said that the potential difference is 12. So must be, how this 12 come? If you relate in place of work, okay, we are closing into our class time. Okay, just a second. Work equal to work, how much work? 12 joule divided by 1 coulomb. What this 12 volt tells you, Prithvi, that 12 volt means what? How it come? It means that it is telling you for 1 coulomb of charge, if a battery said it is 12 volt, it means for moving 1 coulomb of mamma, means telling me battery is forcing you. That battery has a capability to force 1 coulomb of charge. That how much work it will do on 1 coulomb?
12 joules.
12 joule. Means the battery tells you for 1 coulomb, I will provide 12 joule, and so that its capability will be 12 volt. Okay. So if I ask you, if something, in household, in our home supply, the standard voltage is 220 volt. This is your exam question also, right? All of you know 220 volt.
Yes, sir.
Yes,
Here
sir.
this word 220 at domestic household. What exactly this 220 volt is being used? Okay. What this mean? If you want to apply this same thing to your home, 220 volt, potential difference equal to work by charge. Now you can relate that in my home, for moving 1 coulomb of charge, how much joule is spent? 220.
220.
This one is a standard supply at your home. Voltage can be up and down, right? So, but the standard one is like for forcing 1 coulomb of charge, there is a supply of 220 joule. 220 joule. Joule is work. Work is related to energy. All of you know work and energy is the same thing.
Yes, sir.
When you come to leave it. What amount do you work now? That much of energy is lost. If you say that I have come from running, you have done a running work. And if you are doing that work, some energy must be lost. Okay, some energy must be lost for doing the work. So if someone is doing 220 joule of work, it means it is losing energy. So that for that you are charged, right? Electricity bill aata hai na, 2000, 1000. They are taking this charge, this joule, 220 joule charge. They are supplying energy, electrical energy that we use. I will teach you. Okay. So all of you realizing from very basic what I'm trying to convey, I teach you very basic thing. I equal to Q by T, V equal to W by, you must have heard. But what I'm trying to convey you here is very basic thing, which make you lively. Yeah. So we just study, but we don't make it lively. So that thing I'm trying to do. Okay. Okay, guys.
Okay, sir. Thank you,
Okay,
sir.
so like, oh, thank you also, I got, okay, fine, dear. So like today we have English class only, so do join that, okay,
Yes.
fine. And whatever the homework will be, do it, because it is a theory only, do after that, okay. And give your suggestions to me, what should be better or not, okay. I want to connect with you guys, okay, fine. I will
Yes.
provide the recorded session. You saw I provided a YouTube channel, Prakash Kumar Oda class. That is that I had made for you only, guys. Okay. So be active on that. Okay.
Yes,
I will.
sir.
I have whatever the sessions I had also like taken earlier. I will upload there also. Okay. That also.
Yes, sir.
Fine, guys. Okay. Keep studying. Okay. Be motivated and keep studying. Bye.
Thank you, sir.
Welcome.
Bye, sir. Thank you, sir.
Bye.